All right, so I think this is recording. Let's take a look here at number 5, this polynomial function of degree 4, and we want to find all the zeros of this function. Remember that zeros are just another word for x-intercepts, and sometimes they used to call them, most of the textbooks when I was in high school called them roots. They didn't use the terminology as zero as much as they did roots. So it would say find the roots of this polynomial function. All right, so we don't see any greatest common factor. This is in standard form with no missing powers on our exponents, 4, 3, 2, 1 constant. If we look at the factors of our constant term, that will help us to create a list of possible rational zeros. The factors of our leading coefficient here are 1 and 2. Now, we're going to use these in the numerator and these in the denominator to create a list of our possible rational zeros. So let's do that. No guarantee that any of these will actually produce any zeros. And if they do, they're only rational numbers. They won't produce irrational numbers like square root of 2 or square root of 3 or anything like that. All right, so let's take each value in the numerator and divide it by 1. And now take each of these values and divide it by 2. Since 2 divided by 2 is 1, we're not going to add it to the list. And 4 divided by 2 is 2, and it's already there. So we're not going to add it to the list. Once you're in, you're in. So here's our list. All right, so now let's try to see if we can't find, I always just start with 1. Some of you that are more gifted at looking at these values and just in your head seeing whether the numbers add up to 0 or not might be better at going through and picking. Just make sure that you're organized enough that you don't waste time checking the same number more than once. All right. Well, more than once if it doesn't give you a 0. If it does give you a 0, sometimes you do have to test it more than once. All right, 4, 3, 2, 1, yeah. All right. We found one. All right, so this was of degree 4. This is now of degree 3, so we still have to keep looking. It's possible that this could be a 0 of multiplicity greater than 1. So let's go ahead and check and see if 1 wouldn't give us a 0. And it doesn't look like it's going to. All right. So let's try a -1. But I don't think it's going to either, is it? Nope. So we've tried 1 and -1. Let's try 2. This has promise. There we go. So this polynomial function rather than having it written in standard form, we can try to write it in factored form. Zeros of 1 and 2 in factored form are x minus 1 and x minus 2, and this 252 is a quadratic. Now, it's possible that this quadratic could be a parabola entirely above the x-axis, and maybe it doesn't give us any zeros. Or maybe it doesn't factor, and the quadratic formula would give us irrational zeros. I think this is going to factor. So your x method should be able to illustrate that it factors to 2x plus 1 times x plus 2. So if you don't see that, the x method has you sketch an x. Some people sketch it directly over the middle term, and that's fine. I usually do it off to the side just so I don't clutter up all of my work. The first term times the last term goes at the top of the x. And you want two numbers that when multiplied together give you the top expression, but when added give you the bottom. And 4x times 1x does the trick. Since the leading coefficient is not 1, I suggest that you come down and work in a table where you write the first term and the last term along one diagonal, and the two values that you found in your table along the other diagonal. So now you factor both horizontally and vertically, and you get the 2x plus 1 and x plus 2 that I thought that we would get. All right, so our zeros, I'm just going to write it horizontally this time. Our zeros are 1, 2, negative 1/2, and negative 2. It was of degree 4, and we found 4 of them, so that's the most that it can have. So pretty sure that that's correct and that we're done. All right, well, I'll talk to you later. Bye.